On a July afternoon in 1878, high above the Brooklyn Bridge's stone anchorage, a finished cable strand was being lowered into place. Thomas Blake stood beside the rope holding it. A few feet away stood Harry Supple. Neither man knew the rope had gradually been damaged by repeated contact with a pulley. It had already passed through more than a dozen times. It let go without warning. Blake was killed instantly. Supple was thrown 80 feet to his death in the yard below. Picture it, a rope tested to 6 times its working load, snapping anyway, in the middle of making the very cable meant to hold up a bridge. Millions of people cross a suspension bridge like this one every year without a second thought. So how does anyone actually build a cable strong enough to carry one? A suspension bridge's entire deck hangs from 2 or 4 main cables slung between towers, and those cables are by far the heaviest single components on the bridge. A finished cable on a large bridge can weigh many hundreds of tons and run over half a mile long. No factory could manufacture or transport a finished cable of that size in one piece, so bridge builders solved the problem by not building the cable anywhere else at all. They built it in the air, over the water, wire by wire, exactly where it needed to hang. The wire for the Brooklyn Bridge was supplied by John A. Roebling's Sons, the family firm, while construction itself was directed by Chief Engineer Washington Roebling, who took over after his father died from an accident during the site survey, before groundbreaking had even begun. An illness contracted years later in the bridge's underwater foundations left Washington largely confined to his home for the rest of the project. He watched the work through field glasses from his apartment window, with his wife, Emily, carrying much of his instructions down to the engineers on site. On site, the men who actually spun and set the wire were often former sailors, hired specifically because they were already used to working the rigging on tall ships. The process was called cable spinning. A loop of wire called a traveller was pulled back and forth across the river by a wheel running along a track strung between the 2 anchorages. Each pass laid 2 new wires into place. Workers on a swaying catwalk guided the wire to the correct tension and sag as it went, wire after wire, until several hundred of them formed a bundle called a strand. 19 of these strands, bound together, would eventually make one finished cable. Every wire mattered, because Roebling had designed the cables with a safety margin of 6 times the load they would ever actually carry, and that margin depended on every single wire meeting specification. In 1878, Roebling grew suspicious of his wire contractor, J. Lloyd Hay, and ordered every ring of wire tested individually, instead of the usual 1 in 10. His engineers caught Hay's mill swapping approved wire for rejected wire overnight. By the time the fraud was confirmed, roughly 200 tons of substandard wire were already spun into the cables and could not be removed. Roebling's answer was to add about 150 extra wires to each cable, at Hay's expense, to restore the strength the bridge needed. The accident that killed Blake and Supple happened months into that same summer. Master mechanic E. F. Farrington had ordered a finished strand lowered into position at the anchorage, using a steel rope tested many times over for exactly this task. 30 men had worked the anchorage that morning. Only a handful stayed on through the lowering. The rope had run through the same pulley more than a dozen times without incident. This time, its edge had cut into the steel just enough to weaken it. It gave way with what witnesses called a deafening report, throwing pulleys and rope in every direction. Blake never had a chance to move. Supple was struck and carried off the anchorage entirely. The investigation afterward found no negligence, only a rope that had finally failed after years of exactly the kind of repeated use it had always withstood before. Spinning the wire was only the first stage. Once a cable's 19 strands were all in place, workers riding wooden platforms called buggies moved out along the finished cable to bind it into a single solid mass, compressed into a compact cylinder using powerful cable presses until what had been a loose bundle of thousands of wires became one continuous cylinder, 16 inches thick, over half a mile long. The last wire of the Brooklyn Bridge went over the river on October 5th, 1878, 8 months ahead of schedule, after the carrier wheel alone had crossed the river more than 23,000 times. 52 years later, the same company spun cables for a very different bridge. Roebling & Sons took the Golden Gate Bridge contract in 1935, using a refined version of the same technique, this time spinning 80,000 miles of wire across San Francisco Bay. To beat their 14-month deadline, the crew built a second spinning wheel to work from the opposite direction and eventually ran several color-coded wire loops across the strait simultaneously. They finished in barely 6 months, the same firm, using the same principle, moving 4 times faster than anyone expected. The difference between a properly spun cable and a compromised one is not something you can see once the wrapping goes on. It only shows up decades later, under load, in weather, through corrosion. The Brooklyn Bridge's original 4 main cables, fraud, extra wire and all, are still the ones holding up the bridge today, well over a century after Roebling's crew finished spinning them. Only the smaller suspender ropes connecting the cables to the deck have ever been replaced. Cable spinning drew crowds the way few construction projects do. When engineers first tested a temporary wire footbridge across the East River in 1876, an estimated 10,000 people gathered on both shores to watch a single man ride across it in a boatswain's chair. Farrington, marking the completion of the Brooklyn Bridge's cables 2 years later, wrote that the moment passed with almost no ceremony at all, just a steam whistle and a flag raised over the tower. After years of danger and spectacle, the finished cable arrived quietly. The parallel wire spinning method Roebling patented and refined on the Brooklyn Bridge remained the standard for major suspension bridges for more than a century afterward, used on the Golden Gate, the Verrazano Narrows, and bridges built across the world long after the men who invented the technique were gone. Only in recent decades have some builders shifted to prefabricated parallel strand cables, assembled at a factory and shipped to the site in finished sections, for bridges where speed matters more than the extra strength of on-site spinning. Every car crossing bridges like the Brooklyn Bridge or the Golden Gate rides on a cable no factory ever assembled into one finished piece. It was spun in place, one wire at a time, by men working hundreds of feet above open water, wire after wire after wire, until thousands of individually ordinary threads of steel became strong enough to hold up a bridge. Most drivers never look up to notice. These systems shaped the world quietly. If you'd like to see more of them documented, consider subscribing, and tell us which forgotten craft or construction method we should uncover next.